Gucci gang, spent 5 racks on these double frames, yeah, they look to hate.
Okay, good morning. Today, for pre-calculus, I'm going to be covering diagram problems and calculator trig values. So I'm going to start out by doing a few problems that are no calculator kind of problems, all right? Which often means we're going to these two triangles. An awful lot with these two triangles in this particular part of the course. So the 30, 60, 90 and the 45, 45, 90, you're welcome to write these on your formula sheet and refer to them as needed. So if I go back over here, if I'm looking at this and they're asking for solve for x and y, be your directions, pretty simple. I know that, if I can find the short leg of the 30, 60, 90 triangle, that's what this is. Remember, the triangle adds up to 180 degrees, so anytime you see a 90 and a 30, you know the other one's going to be 60, okay? So that's a 30, 60, 90. The short leg is half of the hypotenuse. So if you know the short leg, life is easy. You double it to get the hypotenuse, multiply it by the square root of 3 to get the long leg. The long leg is opposite the 60-degree angle. The short leg is opposite the 30-degree angle, just so you know what I'm talking about. And this is the hypotenuse, okay? Okay, so back to my problem. I know the hypotenuse, right? Hypotenuse is opposite the 90-degree angle, which means y is the short leg, this one, which means if the hypotenuse is 10, the side opposite the 30-degree angle will be half of 10, which is 5. Okay, the long leg, which is x, which is opposite the 60-degree angle, will be whatever the short leg is times the square root of 3, which would be 5 times the square root of 3, and those are my answers. That's it, okay? If they give you the long leg, which is the x, then to find the short leg, you divide by the square root of 3 instead of multiply by the square root of 3, okay? And that can be the one that's a little trickier. We'll get to those later. All right, so back to this one. Once again, looks like they gave me the hypotenuse being 12, which means the angle the side opposite the 30 will be half of 12, okay? So that means x equals 6. Now I know the short leg. The long leg will be y, which is opposite the 60-degree angle, which will give me, if I take 6 and I multiply it by the square root of 3, I will get my answer. So it looks like that. 6 times the square root of 3. That's it. Number 3. This one, a little different. So they gave me the long leg, right? So if I know what the short leg is, the short leg's opposite the 30-degree, which would be my x. Usually they give me the x and I multiply by the square root of 3 to find the long leg. In this case, it's going to go the other way, which means if I divide by the square root of 3, I'll get what x is. Now, with this, you really want to get rid of the radical in the denominator, so you're going to multiply top and bottom by square root of 3 over square root of 3, which will give me 3 in the denominator. Square root of 3 times square root of 3 is regular 3. Numerator is going to be 20 times the square root of 3, and that's going to be my answer, okay? Now I know the short leg, and life is always good once you know the short leg because I can double it to find the hypotenuse, okay? So that means if my short leg is 20 square roots of 3, then the hypotenuse would be 20 square roots of 3 over 3 times 2, which will give me 40 square roots of 3 over 3. Okay? You can just move that 2 into the numerator, multiply it by the regular number, and voila. All right. Number 4. Let's see. They gave me the hypotenuse again. This is good. I like it when they give me the hypotenuse. That means the short leg, which is opposite the 30-degree, will be half of the hypotenuse. So that's 11 divided by 2, or 11 over 2, right? And then if I want the long leg, I take whatever the short leg is, and I multiply it by the square root of 3. Okay, so you'll probably usually see this as that. Okay, you can move that into the numerator. And yeah, that's it. Pretty straightforward. Number 5. Once again, they gave me the hypotenuse. Pretty easy. Which means my short leg, the one opposite the 30 degree, will be half of the hypotenuse, which is 4. X is going to be whatever the short leg is, times the square root of 3, which is 4 times the square root of 3. And there it is. Usually you see it like that without the times sign. There's an implied multiplication sign between there. Anyway. And last but not least, this one, this one's a 45, 45, 90. In case you forgot, anytime you see an isosceles right triangle, that's automatically a 45, 45, 90. The base angles of an isosceles triangle are congruent. Therefore, those both have to be 45 degrees. Okay? So, going back to that original triangle up here, you're either always multiplying by the square root of 2. In this case, if you know the one of the legs, you multiply that times the square root of 2. If they give you the hypotenuse to get a leg, and the leg would be your unknown like this one, then you divide by the square root of 2. So, back to this. So this one, x is going to be 14 divided by the square root of 2. And you can either leave it like that, or if you want to rationalize your denominator, like so many teachers like you to do, you multiply top and bottom by square root of 2 over the square root of 2. And you get 14 square roots of 2 over regular 2, which is 7 square roots of 2. One of those. Those are the same thing, okay? Okay, next one. The calculator section. Now, the calculator part is important here. Make sure you're in degrees in your calculator as well. So, you want to set this up. I like to mark my sides, especially in the beginning as you're getting back to used to this. Which one's opposite, which one's adjacent, which one's hypotenuse. Remember that you're going to be using sine, cosine, tangent ratios for this. This is with regards to the 43 degrees, okay? So the one that's farthest away is your opposite, which would be that one. And then the x will be your adjacent, because that's next to it. Obviously, the hypotenuse is opposite the right angle, so this would be the hypotenuse, although there's nothing there, so I'm not going to be using the hypotenuse, which means I'm looking for which one of those three ratios has the opposite and the adjacent in it, and you should have these memorized by now. Tangent would be the opposite and the adjacent, so I'm going to set that up as tangent of 43 degrees equals opposite over adjacent, okay? And then you're going to solve this. Didn't leave myself a lot of space here. All right, so next, what I like to do is you take the calculator and go tangent of 43, which is the wrong one, 0.9325. And remember, you can always put, the way I like to do these is I like to put this over 1 and then cross multiply and solve, okay? So when I do that, I'll write it over here. I get 12.5 equals 0.9325x. And then I divide by the 0.9325. And I'll get what my answer is. $13.4. Okay. And that's it. Next one. Same idea. Label the sides first. I should have a right angle on it. These are all right triangles. So this is my hypotenuse opposite the right angle. Okay, you can always make an arrow out of that, and it points directly at your hypotenuse, which means the x is the adjacent, because it's next to the 18. which means adjacent and hypotenuse is going to be the cosine. You know, you can look back up at your three ratios. The only one with the adjacent and the hypotenuse is the cosine. I should give a little spot for the angle there. Cosine of 43, and then I can plug in my values. The adjacent's the x, 22 is the hypotenuse, and cosine of 43, once again, make sure you're in degrees, not radians, it's 0.7314. Put that over 1, cross multiply and solve. And if you do this correctly, you should get x equals 20.9. Okay. Number 9. Same idea. Which one's opposite, adjacent, hypotenuse? This one's the hypotenuse. This one's the opposite. Please make sure you're getting that right. It can be brutal if a kid is like on every single triangle putting the opposite side where the adjacent should be. Okay. So opposite and hypotenuse, that's sine 51. Remember, as right back here, the only one with the opposite and the hypotenuse in it is sine. That's how I figured out which one of those three ratios to use, okay? So sine of 51 equals opposite over hypotenuse. So the sine of 51, the opposite's the 15, hypotenuse is the x. Next, take your calculator, go sine of 51. Will give you 0.7771. Put the 0.77 over 1. Cross multiply and solve. And if you do that correctly, you should get x equals 19.3. Number 10. All right, a little different. This time I'm looking for the angle, okay? When you're looking for the angle, you're always going to end up doing inverse sine, inverse cosine, or inverse tangent. Let me write that down for you guys here. All right, so when you're solving for a missing angle, you use the inverse sine, inverse cosine, or inverse tangent, which should be on your calculator, and usually it's the other function. The second function or inverse, you know, -1, it's usually right opposite the sine, cosine, tangent. If you have troubles finding on your calculator, you know, ask me in class. I'll be happy to help you there. All right, so back to this. So I'm going to set this up, same kind of setup. Which one's, this is the opposite side, this is the adjacent side, which means opposite and adjacent is tangent. So the tangent of theta equals the opposite over the adjacent, which means the tangent of theta equals 80 over 100. Next, I'm going to turn that into a decimal. All right, so that's going to be 0.8 or 0.80, either one, equals tangent of theta. Now you're going to switch them, okay? That's what you do the inverse. So I switch these. And I get the tangent, the inverse tangent of 0.8 equals theta. And that's something you can now punch into your calculator, okay? So if I take my 0.80 and go second tan, I get 38.7 degrees, okay? Make sure, once again, make sure you're in degrees, not radians or gradians. All right, this one, similar, except that it's not going to be tangent because this is the opposite side. This is the hypotenuse. So I'm going to be looking at the sine, okay? So the sine of theta equals 6 over 14.5. Remember, the sides always go in the fraction. The angle always goes next to the sine, cosine, tangent. Next, if I take 6 and I divide it by 14.5, I get 0.0690 if I round off slightly. Okay, and now I'm going to do the inverse sine. So the inverse sine of 0.0690 will equal theta. And when I punch that into my calculator, you should get 3. Had a calculator error there. When you punch in 6 divided by 14.5, it's 0.4138, not what I had there, 0.06 something or other. So fix that. And then if I do inverse sine, you should get 24.4. And that's the answer. Okay. Now, next. The next couple here, sine and cosine, these are really like calculator problems. What is important to know is that, if I take the cosine of an angle, it's always going to be between 1 and -1. It could equal 1 and -1 also, but it's between those two. So if I told you that, the cosine of something equals 2, there's no solution there, okay? And we'll get more into why when we get into the graphing. But just know that sine and cosine range between 0 and between 1 and -1, okay? Tangent's different. Tangent, cotangent, those are different. So this, make sure your calculator is in degrees. But if I ask you what the cosine of 221 is, it's pretty straightforward. You can punch it right in your calculator and go, oh, it's going to be negative, and it's negative 0.7547, and that's it. Okay, sine of 178 is 0.035. If you round that off, going 4 numbers past the decimal point. That one had a 0.99, 0.899 or whatever. Yeah, so anyway, that's why that rounded off like that. Notice how those are between 1 and -1, all right? Next one, cosecant of 130. I don't like working with cosecants. I want to work with sines, cosines, and tangents. So hopefully you remember that the cosecant and the sine are opposite. So the sine of theta equals, actually we'll go the other way. 1 over the cosecant is one of the things. Let me move this. Right, there we go. 1 over the sine of theta equals the cosecant of theta. Okay, which means that this cosecant of 130 degrees is 1 over the sine of 130 degrees. And this is much easier for me to work with. Okay, so if I take this, the sine of 130, this will be 1 over 0.7660, which gives me 1.3054. There's your answer. Next one, cotangent of 243. So same idea, okay? Cotangent of 243 is 1 over the tangent of 243, which means if I take that, the tangent of 243 in my calculator, I will get 1.96. Okay, and if I go 1 over that, I get 0.51, approximately 0.510. And there's my answer, okay? Next one, true or false? So these are kind of logic ones. I guess you could punch in your calculator, but remember, secant is 1 over the cosine, right? And this is cosine of 30. You can always put this over 1, and if I multiply those together, you get cosine of 30 over the cosine of 30. And of course, anything divided by itself is 1. So that is true. Next one. Cosecant of 60 equals the secant of 30. This one, if this is a no calculator problem, you can go back to your 30, 60, 90 triangle. Remember, the cosecant's the inverse of the sine. Secant's the inverse of the cosine. So 1 over sine of 60 equals 1 over cosine of 30 is the same thing that's written up there, just written differently. Which means if I go and figure out what the actual sine of 60 is, sine is the opposite over the hypotenuse. Sine of 60 would be the square root of 3 over 2. And the cosine of 30, cosine is also the square root of 3 over 2. So those two things are the same thing. That makes it true, huh? I don't have to go figuring out what those are. You flip and multiply, but that's true. I just have to spell true correctly. There we go. Next one. Sine of 40 equals plus cosine of 40 equals 1. This one's totally false, all right? If you punch that into your calculator, you get very different numbers. The sine squared of something plus cosine squared of something equals 1. This does not. So there's no way that's going to work out. Okay, all right, my last section here. A point on the terminal side of an angle is given. Find the value of the 6 trig functions. So I'm going to draw this out on a graph, all right? Negative 2, 3. Make a quick graph over here, okay? Negative 2, and then 3 is up here, which means here is my point. So this always goes to the origin, okay? And then this is going to be my right triangle. There is my theta. Okay, now remember, this is the negative 2 right here, and this is the 3. So the height goes up, and the negative is on the x-axis, okay? And that's important because, when I start talking about sine of theta now is going to be opposite over hypotenuse. This is the opposite. I just need to find out what the hypotenuse is, okay? So for me to find the hypotenuse, I'm going to go negative 2 squared plus 3 squared equals c squared with the Pythagorean theorem, right? So that's 4 plus 9 equals c squared, and c equals square root of 13. Let me draw that one in there. Okay, now I got everything I need. So the sine is the opposite over the hypotenuse. I'm going to leave it like that with a radical on the bottom. I'm not worrying about that. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, which is 3 over negative 2. All right. And then for all these other functions here, I just flip them, right? Square root of 13 over 3. This one's square root of 13 over negative 2. Remember, the negative can go in front of the fraction, the bottom of the fraction, top of the fraction, whatever. I'm not picky about that. This one will be negative 2/3. There's my 3 answers, okay? This one, negative square root of 3, negative 1. Once again, draw a triangle. A graph. Negative square root of 3, negative 1. So, negative square root of 3, negative 1 will be down here somewhere. Okay, draw my line like this. Change some colors. So this is negative square root of 3. This is negative 1. This always goes to the x-axis, okay? So this is my negative 1. Here's my theta. Theta always goes between the x-axis and the line by the origin. I'm going to do the Pythagorean theorem to find out the third side of the triangle. So once again, I'm looking for the hypotenuse. Equals c. A squared plus b squared equals c squared. And if you do that correctly, that's 1 plus 3 c squared. C equals 2. All right. So there's that. Now I can go figure out all these other things, right? This one's the opposite. The -1 is the opposite. This is the adjacent. And the hypotenuse is the 2. So opposite over hypotenuse is the sine, which is -1 over 2. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. To find these other three, you just flip those upside down, right? You just have to know which one's which that the sine and the secant go together, that the cosine and the secant go together, and the tangent and the cotangent go together. Okay, there's that one. Here's my last one. So once again, 4, -7, go put that on a graph. Here's 4, here's -7, goes up to the origin and then to the x-axis. And theta will always be between the hypotenuse and the x-axis. So that means this is your 4. Nope, sorry, backwards. That's the -7. This is the 4 along the x-axis. And then if I do Pythagorean theorem, so that's 16 plus 49. C will be the square root of 65 if you solve that out. And now remember that the -7 will be your opposite. This is the adjacent and the hypotenuse, okay? And when I plug those numbers in over here, the sine will be the -7 over the square root of 65. Cosine will be the 4 over the square root of 65. Tangent will be -7 over 4. These are all just upside down. This one's the square root of 65 over 4, and this one's -4 over 7. And those are all my answers. That's all I got for today. Have a wonderful evening, and see you all soon.
Yeah. Gucci gang, spent 5 racks on these double frames, yeah, they look to hate.